Good afternoon, everyone. This is a pretty full room. It must be a FINRA session. I've been at AWS for about 4 years as a solutions architect, working in our federal financials practice. And so I've had an opportunity to spend a lot of that time with FINRA and watch the construction of their big data analytics environment and their data ocean, as I like to call it. They've definitely graduated from the data lake. Again, being a FINRA session, I've been to a number of our summits, reInvents, and this public sector summit the last few years, and I don't remember seeing anything less than a full house. FINRA brings a lot of information to the masses around big data analytics. Today, you're only going to see me for a few minutes, because I definitely am not the star of this show. So I'm going to introduce Saugata Chaudhuri and Babul Kamareddy here in a moment. And they're actually going to give you the real meat of things. But I do want to take a little bit of a dive into the AWS environment that FINRA uses for their analytics. If you've been in one of the sessions before, you've probably seen this slide. They do constantly innovate. They constantly push to bring new services and features to AWS and partner with us. This is a slide from actually 2016. So you see things like Redshift, you'll see EMR. Some of the things that we've actually introduced over the last couple of years as well from the analytics space that FINRA has adopted and partnered with is things like HBase on S3 for EMR, Redshift Spectrum, and Athena. And these are all platforms and managed services that they are either using full on or they are in the process of pushing those into production environments. So a few statistics that I actually wanted to bring up. Oop, wrong way. So a couple of years ago, as they were building out their data lake, they were about a year in. And by that time, they were actually running about 20,000 nodes of EC2 spot instances on a daily basis. So they have a framework that easily brings up and brings down EMR clusters to be able to process and ingest and normalize the data. But 20,000 nodes in a single day, usually less than 2 hours per cluster. And they peaked out around 32,000 nodes in a single day. Their storage, 12 petabytes in Amazon S3, and about 8 petabytes in Amazon Glacier. And they had about 100 million objects cataloged in S3. And when I say cataloged, so they have a pretty large data management environment and a major data catalog where every piece of data that's considered a record actually gets cataloged and is used somewhere else in the environment, whether it's an analytics platform or it's in another one of the downstream applications. One of the statistics actually that I forgot to add to this slide is they were averaging about 36 billion market events a day. So every day they would get around 36 billion on the average. And they did peak out in 2016 at 75 billion. In a single day. Now, up to 2018 so far, if anybody's been watching the stock market, you've seen that there are days when it's kind of quiet, and you've seen days where it looks like a triple loop roller coaster. So right now, 2018 so far, they are at an average of 33,000 nodes a day. And they've peaked out at 53,000 nodes in a single day. Again, the growth of the storage, as objects are coming in and they're maintaining data in the data catalog, 20 petabytes in S3 and 18 petabytes in Glacier. Also, 220 million objects cataloged. Now, the other statistic is, so far this year, they're averaging around 53 billion events a day. And earlier this year, they actually surpassed multiple days of 100 billion events in a single day. What makes these statistics, I think, impactful is the time it took them 2 years ago in a single day to process that 75 billion peak. They actually do this 100 billion in less time with more nodes. So as they've constantly gotten in additional data and they've spent time innovating, they've definitely cracked the nut on speed and maintaining the same level of service to their internal users and their downstream users. So with that, what I'd like to do is I'd like to introduce Shigata Chadabori to move on to the next part of the session. Thank you, Robert.
Well, just a few months ago, I think we all sat down to that really fun task of filling out your tax returns. We opened up all those envelopes that said important tax-related information inside, or we downloaded the files from the websites, and we started reading all that to get ready. Now, among those documents, there were possibly statements from your brokerage houses, brokerage firms, that listed all the trades that you did during the year, the securities you bought and sold, the prices, the dates, the quantities, what you paid for them. That list of transactions, those trades, that's what we call at FINRA a trade blotter. So your list of transactions is a trade blotter for one customer of a brokerage firm. That's you. Now, you may have to analyze these transactions for your accounts, your family's accounts, maybe relatives, maybe parents, and sometimes they do get overwhelming. Now imagine the task of analyzing all the transactions for all the customers of all the brokerage firms in the United States. We're talking of hundreds of millions of transactions into the billions. That's what we aim to do at FINRA. We analyze this data to detect any violations of securities rules. Because at FINRA, our aim is to protect you, the investor, from wrongdoing and bad practices. And today, we're going to take a look at how FINRA is using AWS technologies to achieve its regulatory mission. Specifically, how we overcome the challenges of generating analytics from large volumes of trade blotter data. We're going to look at the business process, the challenges we had, how we tried to do it using non-cloud technologies, the hurdles we faced, and then how AWS came to your rescue. So let's start with, who is FINRA? FINRA is a self-regulatory organization of 3,700 brokerage firms. These are all the brokerage firms in the United States. If you have a brokerage account, your firm is a member of FINRA, and we regulate them. Our mission is to make sure nationwide all investors are protected and the markets stay fair so that you, investors, me, investor, we have confidence to trade in the market. Our jurisdiction is defined by the federal securities rules, the FINRA rules, and various other rule sets. We deter misconduct by enforcing these rules. Every day, coast to coast, our regulatory staff, our examiners are out there inspecting the operations of the brokerage firms and focusing on those areas that are of highest risk to the investors. We detect misconduct, such as fraud and insider trading, by analyzing huge volumes of market data. We are a strategic partner of AWS, and we are a leader in use of AWS services and technologies, using which, as you just heard, we peaked at 100 billion plus transactions in a single day. We analyzed them. And an average day for us is, 60 billion, nothing much. When we do find wrongdoing, we take actions against the violators. We can fine them, we can suspend them, we can bar them from the industry. Today, we're going to take a look at how AWS is helping us in the detection of regulatory risk using blotters. Now, the process of enforcing rules starts with FINRA collecting a wide variety of data from our member firms. These are financial data, operation data, transaction data, supervisor data, controls. We look at this data, we transform it, we add more data to it, and then we generate analytics from this. These analytics highlight those areas in the firm's operations that are of highest risk to the investors. Our examination staff, our regulatory staff, they cannot possibly examine every aspect of a firm's operations. That's not just efficient. So they use this analytics to hone their focus, to tailor their focus on those areas that could possibly do most harm to the investors, the most risks. What are the examples of such things? For example, it could be excessive commissions on your trades, excessive trading in an account to generate revenue for the broker, excessive markups on the prices of the securities, sales of risky securities to a broker to an investor whose objectives are not in line with those. There are many other such violations that we look for. So before we go to inspect a firm, we ask for the trade blotter from that firm. So that's all transactions of all customers for that firm for a period of time, maybe 3 months, 6 months, a year. So we are talking about hundreds of millions of transactions from a single firm. Now, you may have noticed that the broker statements from the different firms, they look different. The information is the same, but it's laid out differently. And there lies our first challenge. Every blotter file that you get from a member firm is in a different format. And what do I mean by different formats? The data could be labeled differently. The values could be formatted differently. The layout could be different. How a firm identifies a type of trade could be different. Types of trades, canceled trades, rebuild trades, corrected trades, they're all different. The data values themselves may be split into multiple fields. And this is an example of 4 fields. And in a blotter file, we get 100+ fields. To generate analytics from this diverse data set, we have to standardize this data into one single format. Now, FINRA is a not-for-profit organization, and we are very conscious of 2 things: our cost of operations and the cost of regulation, which means the burden we put on the industry, on our member firms, because costs do get passed on to investors. And we have a finite amount of resources in terms of manpower, funding, and of course, time is always against us. So we have to be very efficient in the use of our resources, which means we have to do this standardization and generation of analytics from this data at low cost, high speed, and with high accuracy. That's a daunting challenge. So we started with the hypothesis that we could indeed use technology to automate this process and get efficiencies out of it. But we didn't know to what extent and to what scale. So the first attempt for us was using non-cloud technologies, or what we call on-premise technologies. So let's look at the parts of the process that take a raw blotter at one end and generate analytics at the other. So the first step is collection and standardization. We knew we couldn't get to 100% automation right away. There are too many data formats. We never know what we're going to get. So we allowed for manual intervention by our data operations team, small team, because we need to cost low. And this team can manually look at the data coming in, understand the format of it, maybe understand patterns from it, and set up a configuration for the job to run to standardize it. And they can run this iteratively until we get the correct blotter on the other end. Over time, the patterns build up, and we get a library, and when we recognize a pattern coming in, it's a push-button operation. The second step of this process is to enrich this data with other data. But why? Because that single line in your statement that gives you the name of the security, the price, the quantity, and what you paid for it, and the date, that's not enough information for us to evaluate the risk level of that particular trade, of that blotter, of that broker's behavior with you, of that firm's sales practices with you. We need other data, such as we want to know what's the high price and the low price of that security on that day. What was the trading volume for that security on that day? What kind of security is it? Is it a high-risk security? Further, that broker who executed the trade for you, we at FINRA have information about the broker. We know their regulatory history. Have they been sanctioned? Are there pending actions against them? Have there been complaints against the broker? Have there any patterns of misconduct? So we take all this additional data and fuse it with the blotter data. Then it starts telling us a story about the environmental risk, about the environment, about this trade, about the blotter, about the firm, about the broker, about your relationship with that firm. But the data set just got bigger. And we use our data platforms to automatically do this fusion. And the final step of this process is to generate analytics from this. So these analytics are presented to our examiners, who in a very short amount of time had to make a decision on how to go examine that firm. Which areas are they going to point their attention to? So this presentation of analytics, this rich information that we're giving to the examiners, has to be very fast, very responsive, and very user-friendly. So as I mentioned, our first attempt at this was by using technology we had on hand, our on-prem technologies. And my colleague, Babu, is going to take us in the journey of how we got from there to where we are in the cloud today.
Can you hear me? Okay. Raise your hand if you've seen the movie Incredibles, 1 or 2. Very good. You must be thinking, what's the relation between the movie and this presentation? If you just noticed, what just happened is Robert introduced the AWS services. And they are superheroes, they are characters. Whereas Shagata, he threw a problem, a challenge, and that's the conflict. Now, the rest of the story is on my shoulders. Let's see how we solve this problem using on-premise technologies. To me, they are local heroes. For that younger generation, if you don't know on-premise technologies means, you go to marketplace, buy a server, bring it to work, you build it, you configure, and you deploy. So we build a custom web application for our users to interactively process the trade blotters. As you just mentioned, we have 3 steps in this process. The first step is to standardize a non-standard blotters. So the data ops team takes the blotter, uploads to the application, and iteratively process that. All the transformation logic, the actions performed on the UI are translated into an API call to a traditional ETL tool. In turn, the ETL tool converts all those API calls into SQL-like queries to run on the database. You must be thinking, why can't this be a batch process? As we just mentioned, we expect various formats. We don't know how to process them. We get surprises. That's how we did the first step, standardization. The input is raw, non-standard trade blotters. The output from that step is a standard blotter. Step number 2, as we said previously, we need to combine the standard blotter with additional data sets to tell the entire story. To pull the data from other databases on-prem, we employed DB links to other databases. And we created views and procedures on that database to produce the analytics. The second step is to combine and enrich. The input is a standardized blotter, combine with other data sets, produce analytics, and store the analytics in the database. The third step is to present these analytics to our users. We built another custom web application using JavaScript technologies and data APIs to render these analytics to our users. And the UI quickly highlights the risk areas of concern for our examiners, such as excessive commissions, concentration of risky and complex products. So we started with a hypothesis. Even with such a wide variety of data sets, it is possible to use the technology to automate to a certain extent. And we proved that we can standardize and generate analytics in a consistent and repeatable manner. Phew, that relieves a lot of burden on our examiners. And the shift is focused from processing the data to consuming the actionable intelligence. And this is our on-premise technologies. That's how we solve this problem. So everything was going well until one day when we started receiving a large number of transactions. Here comes the villain. Think of the character Syndrome or Screenslaver from the movie Incredibles. Created 3 problems for us. And we knew we are going to hit certain limitations using on-premise technologies. As FINRA started receiving large number of transactions, the on-prem technologies started to hit its limits of data processing capabilities. Anything over 10 million, either we get errors or it doesn't process. And the second problem, we need to combine standardized blotter with analytics. With large data volumes, we were not able to process, and we were actually not able to meet our SLA. It was getting close to the edges of SLA to deliver the analytics within a specific time. Similarly, the performance on the UI suffered with the data volume. We need to attack the syndrome or Screenslaver. Let's see how we utilized the AWS superheroes to solve this problem. As I said, the first step, the goal is to standardize all the non-standard blotters into a standard structure. The raw blotters data coming in, and the output is standardized blotter data sets. We leveraged what we learned on-premise, and we trained a machine learning algorithm to perform the standardization. And then we need to, the second step is to run this standardization transformation logic to completely standardized. But the problem here is we need power. Think of Mr. Incredible from the movie Incredible, who has lots of power. Ladies and gentlemen, I would like to introduce the AWS superhero, the incredible EMR to process large data sets. We utilized machine learning, and then ETL runs on EMR and stores that data in S3. S3 is a simple storage service Amazon provides. The first pass of processing, it goes like this. The machine learning identifies the format, the ETL runs on EMR, the data profile information, the configuration, and the process the blotter stored in S3. As we said, it's not possible to completely automate this process because we get all the time data surprises. We still retained the human in the loop to correct any processing errors and then standardize. This is the first step. The output is standardized blotter data sets. Combine and enrich the blotter. From the previous step, we have all the standardized blotter data sets, and we need to combine with other data sets, either from a traditional database or from other S3 sources. The output, we need to provide risk analytics. If you remember, on-prem, the storage and the computation power were tightly coupled. And there was no option to scale them independently. They're like tightly coupled. We need an option. We need flexibility to separate them so that I can flex computation power or storage independent of each other. Think of the character Mr. Incredible, who has lots of power, and we need flexibility and elasticity. Can you think of the character? The elastic girl. Just to give a perspective, elastic girl can stand here and stretch her hand all the way to the back and grab your cell phone and retrace it back. So she has flexibility and elasticity. All these powers are there in the incredible EMR. We again used EMR to combine the data sets and to process the analytics. To store all the analytics, we used S3, a simple storage service from Amazon. The output from this process is risk analytics. So what changed? On-prem, we were limited by the computation power. They were actually tightly coupled, computation power and storage. To increase computation power, you have to upgrade the entire server. Here, we have a flexibility to increase the computation power independent of the storage, and vice versa. So 3 things. Amazon EMR's distributed processing capabilities. On-prem, everything was sequential, whereas in cloud, EMR, everything is in parallel. It takes the data and breaks into many pieces and runs in parallel. The flexibility and elasticity allowed us to meet our business SLA. Based on the volume of the data, I can grow or shrink the number of clusters that I need to process. So the 3 things we utilize here: processing power, the flexibility, and elasticity allowed us to process large data sets, analytics, and provide it to our users. Step number 3, analyze and consume. All the analytics are prepared. Now we need to store all the analytics in a store so that users can interactively interact with the analytics. On-prem, we were limited by the computation power of the traditional database. What we did is we appropriately sized Amazon RDS, relational data store, for the given data volume. And we leveraged same data APIs, but we deployed them on EC2 instances to take the advantage of the flexibility and elasticity. The web application, the analytics application is also, we leveraged the on-prem analytics application. We did not change the user interface for our users, but it is deployed on EC2 instances to take advantage of elasticity. And this is how we implemented the solution in cloud technologies, using cloud technologies. When we say cloud technologies, in our mind, we actually look up. But they're in Virginia. Since our hero is superhero is EMR, let's take a detailed look. Amazon EMR provides a managed Hadoop framework which distributes the computation of our data, or your data, across many Amazon EC2 instances. The master instance assigns and monitors the jobs, and all the other instances, they actually do the job. There are two types of instances: core instances and task instances. Core instances can preserve the data for the duration of your job, whereas task instances, they just do the job. It provides additional computation power. So that's how you can get the elasticity. You can shut down as many, you can bring up as many servers you want, and you can shut down as many servers you want. Since AWS superheroes came into our lives, let's talk few benefits, what we got. The problem number one I was referring to, processing large data sets. If you see the trajectory, it's very apparent. We were able to process only 150 million on-prem. After introducing AWS, we were able to process 500 million, and we are on target for 1 billion. You must be thinking, you're talking about the billions of records, why this data set is small? This is a unique problem with a wide variety of data sets coming in. We don't know what to expect. So that's how we started here. What helped us to process that many records? Distributed processing capabilities. On-prem, everything was sequential. In cloud, everything parallel. Number two, throughput. As I said, we need to deliver analytics to our users in a specific time frame to meet our business SLA. On-prem, we were able to support 300 examinations. 2017, we were able to support 1,000 examinations, and we are on target for 1,500 examinations. What helped us? Distributed processing power, elasticity, and flexibility. Based on the size of the volume, I can grow and shrink the number of servers that we need to meet our SLA. The more examinations means more risk coverage, protecting the investor. Response time. As I said, because of the data volume, the analytics performance was suffered. What we did in cloud, we appropriately sized an RDS database to get us the performance what we need. Scalability. The entire Amazon infrastructure is flexible and elastic. At every level, you can grow and shrink based on number of users of volume. Because of that, we were able to scale on-prem cloud solution from 600 to 800 users. We were able to roll out to this many users. Cost. At FINRA, as a not-for-profit SRO, we are very cost conscious, as Shagata mentioned. I can attribute the reduction of the cost, I can attribute it to three things. Number one, dynamic scaling. Based on the data volume, we only utilize what we need. Number two, pay what you use. If we are not using the servers in lower environments, dev, QA, we shut down on weekends and nights. That's how we save the cost. Number three, Traditionally, if a server is in problem, you have to deploy your resources to troubleshoot. Now with AWS, you can just throw away the server and utilize another server. You don't get charged. If we were to scale this solution with this data volume for this many users, it is cost prohibitive. Just to give a perspective, if you take 10 million data set, we almost saved 4x. Security. At FINRA, we take security very seriously, and it is the #1 priority. This stack, the security is implemented at all levels. At rest, the data in S3 is encrypted using Amazon KMS service. And FINRA owns the key. Nobody can get to that data. When the data is transferring between the systems, it is encrypted in transit using SSL. EMR distributes the computation, right? So between the computers, the communication between all those computers is also encrypted. On the application side, RDS is encrypted at rest. Using HTTPS, it is encrypted in transit. Any restricted confidential information is also obfuscated on screen from the users. In summary, we started with a hypothesis and a challenge. We solved the problem using on-premise technologies to a certain extent. We then leveraged AWS cloud technologies to solve the issues. In the end, we were able to take the non-standard raw blotters on one end, put a pipeline together to produce all the analytics that our examiners need in a consistent and repeatable manner. We've also introduced machine learning to identify various formats. In addition to that, we are exploring many more areas to become more efficient and to become more efficient regulator. Our future plans are Amazon's way of saying this one, since you used EMR, may we suggest these services? That is this slide. Amazon QuickSight. It's a cloud-powered business intelligence. Are there any more words? It's a cloud-powered business intelligence. As I said, we implemented a custom analytics application. If the features are available in the market on any tool, we thought of augmenting the existing application with the features that are available in the market, such as pivoting on large data sets. In addition to providing the standard analytics to our users, we are planning to give a freedom to our power users to explore raw data sets. Amazon Redshift provides faster performance, whether it is an ad hoc analysis on raw data sets or a frequent analysis on standard data sets. And we are evaluating that. Amazon machine learning. We used to identify the formats in the processing pipeline. We are planning to extend machine learning capabilities to predict the risk take some human intelligence, and create some models to predict the risk. Apache Kylin. This is open source distributed analytics engine designed to provide SQL interface and multi-dimensional analysis on raw, extremely large data sets. We are evaluating both together Amazon Redshift and Apache Kylin to give a freedom to our power users to explore raw data sets. That means they can identify more risk areas in the raw data sets, and we can make them as a standard analytics and roll out to all the users. Today, when we came in, they gave us this badge, and it was wrapped in a plastic cover. Did you, anyone, raise your hand if you read the instructions from that? You know, very few. We tend to don't read instructions. And you know, this is a charging cable. You can use this as a charging cable if you don't know that. That's what it says on that small piece of paper. My point is, we are getting modernized. If a message pops up on your cell phone, you will read it. Those are the modern interfaces. When a user have a question, today they have to call or navigate through series of web pages. Do you think they will go through series of web pages? No. We are planning to provide a conversational interface for our users to get answers instantaneously. For that, we are evaluating Amazon Lex and Amazon Lambda. Before I close and give it to Shagata, three things. I would like to thank my team here, sitting here. Can you stand up and give them a round of applause, please? They will answer all your questions. Number two, during the Q&A, please don't ask me about Incredibles movie. No questions on that. Number three, if you see any discrepancies with your account statement, please don't call me. Call Shagata if you want. I'll give his phone number later. Thank you.
Thank you, Babu, for the very interesting journey, and especially the incredible EMR, the superheroes. So you got a glimpse today of how FINRA is using AWS technologies to solve its business and technology problems. But the question is, how did we get this good with AWS? First, we partnered with AWS. We worked very closely with their architects, developers, product teams, designers, engineers. We provided feedback to their products, which they incorporated into their product roadmaps, and we both got better together. Second, we trained all our development staff in the use of these platforms and technologies. We ran academies, boot camps, coding sessions, hackathons, create-a-thons, and we unleashed the power of AWS through the development team. To us, every developer is a center of innovation. Unlike many other places where you have centers of excellence and anointed groups that thou shalt do this, thou shalt do. We don't believe in that. Every developer is a center of innovation who comes up with new ideas every day. And that has been made possible by AWS lowering the cost of entry into use of advanced technologies such as AI and ML, and by making data easily accessible, lowering the barriers. Third, we implemented a very well-planned and well-thought-out vision for DevOps. We implemented practices that are ingrained in our development DNA. We have highly automated processes that go all the way from build, test, deployment, configuration, monitoring. Everything is governed, and that entire process is meant to relieve the dev staff of a burden, what used to be DevSecOps before. So through this process, we all matured together, and that's how we got to 100 billion plus transactions successfully in one day. It doesn't happen overnight, but it has to be planned, it has to be thought out, and it has to be disciplined. So I hope you gleaned some insights, and you'll be able to use these approaches, some of these, to solve problems in your own business and technology domains. And furthermore, next time you open your broker statement or you log into your account, think of us looking out for you. Thank you.